Hola a todos, mi nombre es Sandeep y me complace compartir con ustedes hoy algunas consideraciones clave sobre la evaluación de modelos de lenguaje grandes para su uso en la atención médica. Este es un tema importante y oportuno a medida que estos poderosos modelos de inteligencia artificial ganan terreno en todas las industrias, incluida la atención médica. Ahora cambio al inglés. So the outline for today's presentation is first we'll talk about what are large language models, and then we'll talk about the applications in healthcare. And the important component of today's presentation will be discussing the evaluation approach towards large language models in healthcare context. And then we'll end the presentation with discussion around the governance aspect. Now, we got to remember large language models are part of the larger generative AI family. There are other models which form part of the family, including general adversarial networks, VAEs, FBMs, and EBMs. And all of them generate some sort of data, including text data, image data, and synthetic data. And it's important to distinguish between generative AI and discriminative AI. Discriminative AI basically categorizes or classifies data. Generative AI generates new data based on the trained data. We are not going to discuss the other models of generative AI, but we're going to focus on large language models today. So what are large language models? Large language models, as the name indicates, have been trained on large amount of data. And when we look at large language models like ChatGPT, they've been trained on the data that is available on the internet prior to September 2021. And it includes websites, articles, blogs, and so forth. But when we look at the computational architecture of large language models, which you can see on the slide, basically they take the text and they break down into tokens or small parts of the text, and it runs through several layers. And one of the important layers or the aspects of large language models is the transformer layers. And that indeed has revolutionized how natural language processing works nowadays, but also how large language models can lead to better results. So what are transformer layers, or what are the transformer models? This is a type of model which has two important aspects. One is they can run data in parallel as opposed to sequentially processing data. And the second aspect is that it can pay attention to the context of the sentence. And these two aspects have really made natural language processing much more powerful compared to the previous years, but also in terms of large language models to be able to give precise results. Now, when we look at large language models, they not only can analyze text nowadays, but they can also analyze image data, but also voice data. Basically, they become multimodal in their ability to analyze data, but also that can lead to multi-outcomes. In the case of healthcare, they can provide diagnosis, treatment recommendations, and management recommendations. Let's look at some couple of examples. In this instance, some researchers from Florida have developed this large language model, which they term it as Gator-Tron, which has been trained on specifically on medical data or healthcare data like PubMed text, clinical words, and so forth. And further to that, they've actually fine-tuned it to further make it much more specialized and attuned to medical context. For example, being able to do clinical concept extraction, but also answer medical questions. Now, when we look at ChatGPT, there are several papers that show the usefulness or utility of ChatGPT, but this slide demonstrates the various purposes ChatGPT can be used for, including triaging, translation, medical research, clinical workflow, medical education, and various other purposes too. Now we can fine-tune ChatGPT, or also can use it to populate pre-existent templates. In this instance, you can see an example of how ChatGPT, when you supply medical history, can populate specific templates. ChatGPT also has been shown to be able to respond to medical licensing exams. In this instance, a study showed that ChatGPT can pass the United States medical licensing exams, including the three parts, step 1, step 2, and step 3. So if you consider all those examples, you can potentially start to see large language models as kind of medical foundation model upon which various purposes and functionalities can be developed, including question answering, chart summarization, image analysis, risk stratification, and finding similar patients. So there's going to be multiple uses of large language models. Now we discussed the benefits of large language models, but it's important to consider the limitations or downside of large language models. One of the important downsides is the black box issue. We know that large language models are built on neural networks, and in the past we have known that neural networks, because of the hidden layers or the inner layers, we can't understand the decision-making process, and that's true of large language models. Even though there's some nowadays some techniques called tree of thought or chain of reasoning, that still doesn't address the black box issue, and this becomes a problem in medical context when we do not know how large language models can arrive at a decision. Also, large language models are known to show biases because they've been trained on the data from the web, and web data has biases, and that can lead to problems in the healthcare context too. And one important aspect of large language models, which is very alarming, is that they can make up answers, and this is called as hallucination or confabulation. In this instance, you can see an example of a question where we ask a large language model, in this instance, ChatGPT, to identify a non-existent character, and it makes up this answer. Further to those limitations, we also know it takes huge amount of computational infrastructure to develop large language models and also run large language models. And this is not environmentally friendly because it consumes a large amount of energy, as you can see on the slide. So considering the benefits and the limitations, how do we approach the deployment and utility of large language models in healthcare? In relation to that, I published a paper in the Informatics in Medicine Unlocked, and I'm going to be talking about some details of the paper. So relevant to that paper and relevant to that particular topic is this particular evaluation framework, which has 3 layers. The inner layer assesses the NLP metrics, uses natural language, pre-existing natural language metrics or technical metrics, and surrounding that is the translational assessment, which has 3 components: adoption, utility, and capability. And the outermost layer is the governance layer, which has 4 components: fairness, transparency, accountability, and trustworthiness. So let's look at in brief those 3 layers. So the innermost layer is technical metrics. I won't spend too much time on this because this is an evolving area and is something that is can be borrowed from existing metrics, or if there are new metrics that can be fit into that model. But basically, they assess the coherence and the relevance of the responses. The next layer is very relevant to healthcare, and this is borrowed from a previous evaluation framework that myself and co-researchers we developed and published in the British Medical Journal Health Informatics. I encourage you to look at that paper, but in case you do not have the time, just the paper that I recently mentioned can be looked into. So what does this evaluation framework assess? So basically, it assesses 3 components: the capability component, the utility component, and adoption component. And within that, there are many subcomponents. There's much more detail. But the capability component looks at the intrinsic capacity of the large language model. The utility looks at the usability and the relevance of the model to the community or to the stakeholders. And adoption is how well the large language model can integrate into the health service. So here you can see much more detail to the various components, and that's in the paper which I referred to. I do encourage you to look into the paper for the further details. The outermost layer is the governance layer, which has 4 main components, which is the fairness component, the transparency component, trustworthy component, and accountability component. The fairness looks at whether the data that has been used is free of biases or doesn't lead to further biases. Transparency emphasizes the need to be able to provide some explainability around the decision making. Nowadays, we get quite a few explainable AI frameworks, and that particular layer emphasizes the need for transparency. Trustworthiness is to ensure that there is fully informed consent provided from the patients, but also you educate the clinicians and their patients around the use of large language models. Accountability looks at the medical legal aspect. When things go wrong, who becomes responsible and accountable? So in summary, there is 3 layers to those evaluation approach that I discussed in the paper. There's the innermost technical metrics or the NLP metrics, and there's the next layer, which is the evaluation, translation evaluation, and then the outer layer is the governance panel. In that sense, it not only assesses the technical aspects, but also assesses the safety and quality and the usability aspects of that particular large language model. So I do encourage you to look at that paper and look at its applicability to your particular situation. Now, to summarize the presentation, large language models hold great promise in healthcare, but it's not just enough to assess the core NLP metrics. Like in other sectors, we need to have a different approach in healthcare in order to assess the safety and quality and the risk towards patient. We need to look at various other aspects, and the particular approach that I discussed earlier in the previous slides would be one of the approaches in way that you are confident that you're using a safe and quality a large language model. With that, I end my presentation for today. Thank you for your attention.